now want to look at the next section of networks, looking at a few more definitions. So this is part B. So the first thing we're going to start with this idea of a route or a path. So if you think, for example, just a footpath is a way to get between two places, and that's what a path is. It's a way to get between two nodes. So a route or a path is often a longer sequence. So talking about to get from here to the gym, I've got to walk down the stairs, I've got to walk down a second set of stairs, I've got to cross over by the field, and then I'm arrived at the gym. So there is a sequence of footpaths I need to walk down. So for example, if I look at this network, so we've got a network A, B, C, D, E, F, and I want to see what this route A, B, C, D is. So the route A, B, C, D tells me start at node A, and you're going to connect A to node B. So that's the pathway between A and B. I'm then going to connect B to C via that footpath or road. Then between C and D, I'm connecting them together. D and E has been connected, and that there is your route. So that is an example of one route. There are lots of other routes I could do for that diagram, but here's just an example of a route for that problem, or path for that problem. So if I look at a different example, if I think about A, C, E, so I start with node A, node C, and node E, they are not any routes, because between node A and node C there isn't a direct pathway. If I said A to B to C, that would be okay, but between A to C there is no direct arc, so this is not a route. The second thing we've got to look into is what is a cycle or a circuit. So if you think about going to the gym and doing a circuit, you go around, you start at one piece of equipment and work your way around and end up at the same position. Okay? If you're on a walking track, you start somewhere, go for a walk, end up back where you parked your car. That's what a cycle or a circuit is. So here's an example of that. I'm taking my network and I'm going to start, and I've said that this bit here, B, C, E, F, B, that is the circuit. So let's have a look at what that involves. So there's node B, then I'm connecting node B to node C, and node C I'm being connected to E has been connected to F, and F has been connected back to B. So there is a circuit, okay? That is a pathway that starts and finishes at the same node. It starts at node B and goes all the way around in a loop to end up back at node B. So that is an example of a circuit or a cycle. If I was to look at this one here, B, C, E, F, this is not a circuit or a cycle. So let's have a look at why not. So it says start at node B, then connect it to node C, then connect to node E, then connect to node F. So what we've done. We've connected B to C to E to F. But we're not starting and finishing at the same node. We're not starting and finishing at node B. We're starting at node B and finishing at node F. So that's why this is not a circuit. The third thing we want to look at is what a tree is. So I want you to think about an actual tree. Okay, think about branches. Do those branches grow into each other? Do they connect together? No, each branch is a separate branch on its own. So we need to think about branches as being our arcs, and we've got to think about one pathway. So to get from one branch to another branch, there is one pathway that you need to walk. There aren't any loops in this, okay? Branches can't grow into a new branch, and there aren't any circuits, so we're not looping around. So here's an example. This one is an example of a tree, and there aren't any circuits. There's no loops that I could go backwards and forwards and round in. Okay, so that is a tree. It's just got a whole pile of branches or arcs. This example here though is not a tree because it has got a circuit, and that circuit is this one here. So C to D to E, there is a circuit that you could go round and round and round and round, okay? So because it's got a circuit in it, it's not a tree anymore. It's still a network diagram, but it's not specifically a tree. Another thing we need to know about is the arc weights. And so each arc that we draw, okay, will have, or each arc or edge or that we draw is going to have a weight on it. So a weight could be in terms of a distance, road maps. It could be the weight of objects. It could be a cost of building new roads, a cost of laying out cables. It could be the time it takes to do a job, etc. So for example, if I go back to our map of Macaulay High School here, we've got our different roads going all around. So each of those arcs is a road, and what I've done is I've estimated the distance using Google Map. I've estimated the distance of each of those pieces of road. So those are my weights. So these arcs now have weights on them, and those weights represent the distance to get from one corner to another corner. So let's have a look at a different example. I want us to find the total distance for the route ABCE. So the first thing we're going to do is identify the route ABCE. So we're going to start at node A, and we've got the arc going between node A and node B. And that has a total distance on it to get from A to B is a distance of 2 kilometres. So my total distance is I'm going to start by adding on that 2 kilometres between A and B. Now I'm going to add on the arc that goes between node B and C. Now that arc is a distance of 6 kilometres. So I'm going to add on another 6 kilometres to my distance. So to get from A to B, somebody's walked 2 kilometres. To get from B to C, they've walked another 6 kilometres. Altogether so far, from A through to B through to C, they would have walked 8 kilometres. Now we also need to go on to node E. So that is a distance of 4 kilometres more that we're adding. So we're going to add on that distance of 4 kilometres, and that means the total distance for somebody to walk from A through B through C to E, it's going to be 12 kilometres to walk that specific route. Okay, so there's our route and our total distance. What I want you to do now is go to page 9 and exercise B there, and I want you to answer all of the questions in this section. And again, we've got to push through this one, so you need to complete these exercises in one lesson. There's no extra merit excellence part in this one, just everyone needs to do this exercise and complete it in one session.